This is a biological molecules question about water. So it says ponds provide a very stable environment for aquatic organisms. 3 properties of water that contribute to this stability are as follows. The density of water decreases as the temperature falls below 4 degrees C. So the density is decreasing, therefore ice floats on top of the pond. Okay, so that's important. The ice floats. It acts as a solvent for ions such as nitrates, so NO3 minus. So the important bit here is it's a solvent, so molecules will dissolve into it. And a large quantity of energy is required to raise the temperature by 1 degree C. Okay, so a large quantity of energy by 1 degree C. So that means its temperature stable. It requires a lot of energy to change the temperature by even 1 degree C. It then says, explain how 3 properties help organisms survive in the pond. So we've got to talk about these 3 properties. Right, so ice floats. That's the first thing we've got to talk about. And that's because, so that means that ice is less dense than water. And that's because the molecules of water in ice spread out. It forms a crystalline structure, or you can say lattice. So what does that mean for living organisms? Well, the ice forms an insulating layer. And that means the water below it, below the ice, will not freeze. So it remains liquid. So that means the organisms don't freeze. And the organisms can still swim. We've got liquid water that they can swim in. And you could also say that that allows currents and nutrients to circulate. In the body of water. So all those marking points, 7 marking points, are purely about ice floating, because it's less dense than water. Okay, second bullet point is to do with solubility. So because water is a charged molecule, ions are also polar or charged. So, for example, NO3 minus. So therefore, the ions will interact with water. Water is H2O. Oxygen is delta negative and hydrogen is delta positive. So if you've got NO3 minus, that's that negative charge, it will be attracted to the hydrogen. So it will interact. Therefore, if it interacts, it'll dissolve. So nitrates will dissolve in the water. So what does that mean for living organisms? It means that if there's ions dissolved in the water, plants can take up ions, e.g. magnesium or nitrate. And then they can use that magnesium, for example, to make chlorophyll, or the nitrates to make proteins. So that's why solubility is important. So that's the second. So we've spoken about done density. We've now talked about solubility. Okay, the third point we've got to talk about is that it's temperature stable. So it's temperature stability. So the reason that it's got temperature stability is that there's many hydrogen bonds in water between the molecules. So that means a lot of energy is needed to break the bonds. Which means water's got a high, from your chemistry, specific heat capacity. So what does that mean for living organisms? It means that the temperature of the water does not change much. It takes a lot of energy to change the temperature even by 1 degree C. So that means the metabolic rate or enzymes kept at constant temperature. So it could be the temperature that the enzymes work best at, the optimum temperature. It also means any dissolved gases remain soluble, dissolved in the water, therefore available for the organisms in the water. You think about when you boil a kettle, the dissolved gases leave the water. That's why you see the large bubbles. So the 3 marking points we have to talk about. We have to talk about the density of water, water acting as a solvent, and water being stable, requiring a lot of energy to change by 1 degree C, and link it to how it helps organisms to survive. So we've talked about how ice floats, we've talked about solubility, and we've done about temperature stability.